Okay, so in this video, we're going to talk about how to graph systems of inequalities. So graphing a system of inequalities is the same as graphing inequalities, except for the solution of the system of inequalities is the set of ordered pairs satisfying both inequalities. So you've got to have two inequalities and they're going to cross just like systems of equations, but there's obviously going to be more than one ordered pair because of shading. Okay, so this looks like a mess. Let me explain what it is. So first we have our first inequality. Y is greater than x plus 2. We know this is going to be a dotted line because there's no equal sign, so I've graphed it right here. And then you can see where I shaded it up here in red. Then we have y is less than or equal to negative 2x minus 1. And it's going to be a solid line because of this less than or equal to. And I graphed it here in green, and then you can see where I shaded it below it. Now, the answers to our system are going to be right here, where I have both red and green shading. So where they overlap is where all of your answers would be. Okay, so let's look at another example. So in this one, I've already graphed it, however, I have not shaded it. So one of my equations was y is greater than or equal to negative 2. So I drew a line straight across at y is equal to, or greater than or equal to negative 2. And my other one was originally y minus x is less than 1, but I changed it around to be in slope-intercept form, y equals mx plus b. So it was y is less than x plus 1, and that's going to be a dotted line. So I have both of them graphed. So now we just need to shade. So this is greater than, so I know that all of this is going to be shaded. And this one's less than, so I need to shade over here. So our answer would fall right in here in our solution, because this is less than my red but greater than my green. Okay, so it does end up being kind of a scribbly mess when you get done. All right, what about this one? Now this one, I graphed it a different way. Neither one of these are in y equals mx plus b form. They're both in standard form. So I've graphed them using what we did in Unit 6, using my x and y intercepts, where if I make my y equal to 0, I can find that my x-intercept is 2. If I make my x equal to 0, I find that my y-intercept is 4. So I graphed it that way. If you're more comfortable moving it into y equals mx plus b form, that's fine. I'm just showing you that there are options. You don't always have to transform that equation. So I went ahead and graphed them this way, but I haven't shaded yet. Now, shading is a little more difficult when you have them in this form because you can't look right at it and see. So what I did was I picked a point on this graph. So I picked the origin, 0, 0, because that's very easy to plug in. Now, when you pick it to plug in, you have to make sure it doesn't actually fall on either line. And in this case, it doesn't, so we can use it. So if you come down here and you plug it in, 3 times 0 minus 0 is going to be 0. So you end up with 0 is greater than 6. That does not work. 0 is not greater than 6. So in other words, this is a less than equation. So that means that this, we would shade down here. Okay, if it had worked, we would have shaded on this side. So let's look at the other one. 2 times 0 plus 0, of course, is 0. And 0 is less than or equal to 4. Well, that does work. So in this one, I want to shade the positive. So that means that we have our answers right in here. All of our solutions are going to fall right there. So remember, when you're graphing systems of linear inequalities, you graph them both just like we did when there was one, and then when you shade, you look for the overlap. So you can use two colors or shade with different dots and dashes, whatever you need to do to help it really stand out. And that's graphing systems of inequalities.